So we started looking at cost benefit analysis, which is comparing costs of developing information system and also the benefits that you will get once you develop the information system. So why we need such a analysis? We need to find out how economically feasibility of this, whether this decision is bringing value to the organization. This is exactly what we are trying to discuss it here. So under this, we are planning to discuss three types of analysis: payback analysis, return on investment analysis, and present value analysis. And last time I covered the payback analysis. So let me briefly cover what payback analysis means. We know that when you are developing an information system, the you need to spend quite a lot of money in the beginning to develop the system, and then after some time, it will gradually reduce and it will be constant throughout, and then after some time again it will increase the cost. The reason for declining here is like once you finish the development, there'll be a bug fixing and all. You have to spend some money, but when you have finished done with the bugs, then it will be just maintaining the information system, which is constant. And after some time, any system you have a lifetime where it will start, giving errors and so on. That's why it's rise like this. Similar to the cost, if you look at the benefits, initial development, you won't get any benefits at all. But when you start using the system, you will realize that there will be benefits. And then, you will see that it will get to a maximum point in time. But what payback period is amount of, cost that you spend for the system and amount of, benefits you get. When they equal, that means you spend something and then you get the same, how long it will take to get back the same, which we call the payback period. So that's what we have shown here with the dash line. Right. And to do that, we also discuss a couple of, one of the examples where in the project A and project B, and this is the number of years and cost and the benefits are given. So what you need to do is you have to look at the cumulative cost and benefits. When this will be the same, that will be your payback period. For both the cases, you will see year 4 and 5, the cumulative benefits passes the cumulative cost, which means it's actually a positive benefit to the organization. So between 4 and 5 years, for both the cases, you will see we will get the payback period. And ideally, this could be done in a spreadsheet environment like this. And if you've done this to project A, if you plot the cost and the benefits, when the two line means that the payback period, which is more close to 4 years, whereas project B, you will see it will be more towards the 5 years. And you see that if you compare project A and project B, based on the payback analysis, project A would be the best one to choose. Right. And let's start looking at the next type. This is called return on investment. Now, one of the problems in the previous case, we have not thought about the total benefits you will get compared to the costs you spend. So therefore, return on investment, we compare both the total benefits and the total costs, and then we get it as a ratio. And this is known as return on investment, OROI. So for example, what it means, cost and benefits over a longer period of time. So the payback period is the place where you actually meet the cost and the benefits. But in this case, you can look at for the total cost and the benefits, right? Okay, so if you perform ROI, so what will be the ROI value? And usually this will be put it as a percentage value. So can you take down this equation first? Yes. And then we are going to use that to calculate. Okay, so this is the equation you should know. So I'll put in the chat. Yes. Okay, given you that, okay, can you go back here? Can you calculate the ROI for the project A? Yes. What is ROI then? So you can say ROI equals total, okay, we can say total benefits minus total costs and divide by total costs, right? So if you put in this form, can you put down the values? So what are the values? Yes. So look at the whole total cost. So total benefits, like it's 213,000, right? So 213,000 for project A. Subtract total cost 181. Yes. Divide by 181. What is the value? So this will be, yes, around 0.1768, right? Roughly as a percentage, you can say it's around 17.6%. Or you can say just 18%. Yes, agree. Okay. So that's the ROI for project A. Now, similar way, can you calculate the ROI for project B as well? So this is for project A. So let me put this as project A. So what about the ROI for project B then? Yes, give me the answer. Right. If you do this, you can notice that for project A, it's about 17.7. And then for project B is around 33.3. So in that particular case, we can say you have more ROI for project B. But remember, the analysis is slightly different. When you want to analyze, so when we want to analyze these amounts, remember, usually we will specify a minimum ROI. So that means they will say, at least we have to have 15% ROI. Whereas in our case, you can notice both project A and project B meet the criteria. So therefore, so the company can select any of these two projects since it meets the minimum ROI. But you can say that project B is better than A, right? But remember, both will meet the minimum criteria. So there was a question about how to get the cumulative costs. So that is already given. So for example, if you go back and look at here, so these are the costs incurred in the initial years, and this is called cumulative cost. That means costs are added. For example, initially it's 60,000. Next year it's 17,000, which added up to 77,000. So likewise, cumulative costs are after 6 years, 181,000. Similar to that, benefits are also same. Initially it's 3,000, then 28,000, 28 plus 3, it's 31,000, which means when it's cumulative benefits, you will see 213,000. So once you know the cumulative cost and the benefits, calculating ROI means simply we put the total benefits and total cost and you divide by the total cost. So I hope you understood that. Yes? Right. Okay. So having said that, just again, I'm reminding, remember, usually organization state a minimum ROI. So in this particular case, assuming that it's 15, our board projects actually meet the minimum requirement. So therefore, we can select any of these. But of course, we know that since we are getting more return of investment, the project B is better than project A. Right. Now, one of the problems with the return on investment is we don't consider the time period. Because although we will say that, okay, you get a lot of the cost and the benefits, the cost and the benefits are realized in the future terms. So that means if you have 100 rupees today and if you have 100 rupees next year will not be the same. So therefore, when you're calculating projects where it will span for several years, we need to consider this timing effect as well. Right. Now to look at that aspect, we can do what we call the present value analysis. So in present value analysis, we can also consider the future values, or we can say future dollar is the amount of money. So what it means, if you say like 100 rupees, next year, what is the value for today? Or you can say $1. To get $1 after 1 year, how much you have to invest today? So that's what we are going to look at in present values, right? So usually this is calculated and it's given in the tables. You can actually calculate and see. Those are interest rates that you already know. But normally we can get these values as present value tables. That means you will get information such as the periods and also the interest rates, right? So with these percentage values given to you and with the years, this is what it means. For example, let me take one value here. Let me explain what it means. For example, if you take, if we start with the very first value, right? If you start with the very first value, so let's take this value. So what this value means, if you want to get a $1 with 6%, and this is how much you should invest today, right? So what it means, if you take a calculator, right? If you have 0.943, if you multiply by 1.06, and you will get almost 1. So that's what it means. So if you take this one, for example, what it means, to get $1, right? After 5 years with 8% percentage, this is how much you should invest today, right? And if you take this one, to get $1 after 10 years with the rate of 14%, this is how much you invest today. So that's what it means, right? Approximately today's interest rate, for example, in fixed deposits are something like that. So to get $1, right, with a 12% interest rate after 10 years, you should invest this amount. So that's what it means. You can actually calculate and see if you want, but usually these values are provided. Now, assuming that these values are provided, the next one is how to calculate the values. Now, to do that, we can get an example. Now, for example, let's say, right, you are going to find the present value of $1, 12% for 5 years, right? 12% for 5 years. So you come here, it's 0.567, right? Again, to get $1 with 12% interest rate, and after 5 years, what you should have today is 0.567. So what it means, if you want to find the value of 3,000 today, 12% for 5-year time, then what you should having to calculate that, you get that 3,000 multiplied by this present value, and this is how much you need to invest today, or you have to have today. So therefore, instead of saying that, okay, you will get 3,000 after 5 years, you calculate the present value, which is 1,701. And this is what we will consider in cost calculations. Right. Now, having understand this one, to perform the present value, you have to time measure the cost and benefits. So therefore, you have to consider both the projected benefits and the cost with the present value factor. And then you have to sum all the time adjusted benefit and time adjusted costs. And when you calculate the net present value, that means if you take the total present value of the benefits minus total present value of the costs. So if you have a positive net present value, we can say it's economically feasible, right? So therefore, we can use this to compare and rank any projects. So all these, right, we can say the highest net present value should be our best investment, right? So now let's perform the net present value analysis for project A and project B, right? Now, to do that, what you need to do is you have to go back and you have to calculate the values, right? So therefore, each of these values, you need to realize the amount of the present value for today. So we need the cost and the benefits. So let's take, let me share this slide. Take a screenshot of this because we need for the calculations. Done? Okay. So now what I'm going to do, we can get, for example, a spreadsheet to make those calculations, right? So let me take a spreadsheet. Right. So I have a spreadsheet. So I will type, I'm going to say project A. And then these are number of years. I'll put 0, 1, 2, 3, 4, 5, and 6. And then I can have costs. It's 6,000, 17,000, 18,500, 19,200, right? 21,000, 22,000, and 23,300. Right. Similar to that, let's put project B. So I will say years and then costs. So I will put 0 and 1, and then I'm going to autofill this up to 6. Yes, done. Let's put up the costs, 80,000, 40,000, then 25,000, 22,000, 24,000, 26,500, 30,000. Right. So those are the cost values. Let's take benefits. Right. So I'll put a one line here. Right here, I will put benefits. So we have 3,000, 28,000, 31,000, 34,000, 36,000, 39,000, 42,000. Similar to that, let's take it for project B. You don't have any. 6,000, 26,000, 54,000, 70,000, 82,000, and 92,000. Right. Now, we have to look at, now these are the values we get. For example, the cost will, we need to spend this much of cost in year number 6. And this is the benefit we are getting. Now, we have to time adjust this. To time adjust this, we are going to look at, we have already given a rate. What was the rate? Okay, we have to go for the rate. Okay, what was the value? Okay, we have not given any value. Shall we say 10% then? The percentage value should give us, or maybe we can assume. So assuming like 10%, which is, I think, what we have right now. Let's see what will happen. So I'm going to get 10%. So for the 10%, I have to use these values, right? So let me go back to my spreadsheet. Right. The present values is what we have to look for 10%. So here it's 1 because we talk about year, and after 1 year we have to say this is periods, right? And okay, so in that particular case we have used this. So the right now what we have is, yes. So the net present value for this year won't be changed, right? So after 1 year, this is the amount that in core. So that means that we have to get this one, 10%. This will be 0.909, 0.826, then 0.751, then 0.683, then 0.621, 6 year after 6, 0.564, 0.564, right? The same value we need to copy or everywhere, because with this is with 10%. So I'm going to copy this all the places. Right. So what we did so far for the two projects, we put down all the cost and the benefits and then the present values. So what we need to do, so let's see what we need to do. So during that, what we need to do is we have to multiply each of the projected benefits cost by the proper present value factor. Sum all the adjusted benefits and time adjusted cost. So what we are getting is time adjusted cost and time adjusted benefits. So let's put down that here. So time adjusted costs, right? So what we did, time adjusted costs, and then it will come here as well. Then we have time adjusted benefits. Right. So what do you mean by this is you have to simply multiply them. Now what this means is current value, that is 60,000 in the first year to be 60,000. But after, if you talk about after 1 year time, to when you value $1, and the present value should be 0.909. So we have to time adjust. Simply what we can do, we can multiply this with the present value. So it'll be 60,000. But you see the 17,000 after 1 year, which value 15,453 today. 18,500 2 years time will be 15,281. 19,200 will be 14,400, 14,300, 13,300, and then 13,100. Same will here as well. So we multiply this by the present value. So you can see these are the values, right? Similar goes here as well. We can multiply this with 1, and then it goes like this. Again, you can multiply this with the factor. So these are the time adjusted benefits. Now, the point is you have to sum it all, right? So let's go back. Sum all the time adjusted value of benefits. So we sum all the adjusted benefits and time adjusted costs. So we will do that. We'll sum, right? Can say sum will be equal sum of the costs so that is 146,229. Let's sum it up the benefits. $213,000. Similar to that, you sum up all these values. Sum up all these values. Right. Now, net present value, on the other hand, now we have done this. So how to calculate the net present value? To calculate the net present value, you get the benefit minus total present value. So we can see here the total present value.
So,
Yes.
so is the calculation right at project A? Time adjusted benefits?
Right. There was a mistake I have made earlier. So let's check the values again. Right. Now it is adjusted, right? Is it the same? Okay, this was okay. So now what we have to do is we will say net present value. So benefits minus costs. So in this particular case, so the net present value. So the benefits minus the costs, right? So net present value is benefits minus costs, right? So those are the values. Let me highlight those. So you can see that now it's time adjusted compared to our previous one, right? Compared to our previous one, we have time adjusted our cost and the benefits. And then you can see, although earlier we get very high value, for example, you say the benefits is 42,000, but when you value today, right, it be around like 23,000. So that's what we need to adjust it, right? So this is where we need to, when you compare the different types of analysis. So this will be more useful because now your benefit is calculated based on today, right? Not based on the future value. So you can see that the effect of considering the time factor, right? So that's about the calculations. Maybe you can recheck whether I have done it correctly, right? And see whether you are going to get the same answers. Right, okay then. So the next one is performing this. And to summarize our discussion, present value analysis provides the solution of payback analysis and return on investment. Both cases, the time factor is not considered. So present value analysis considered all the cost and benefits, right? And then again, the present value analysis take into account the timing of the cost and benefits. So this is called time value of money. But it depends on what method used by the company. So sometimes it says often they can use all the three methods because it take different views of the costing. Right. Final task, I will give this as a small individual assignment. Maybe you can take down this, but you can do it at pace, and then maybe you can make the submission. Right. So with that one, we conclude, the first part of today, which we talk about mainly any questions on what we have discussed? Right. Then I will move on to another topic where we will focus on the systems design. Now, all the previous one we talk about looking at the solutions, the feasibilities, selection of projects, and so on. Now, in this part, we are going to talk about the system design aspect. Now, system design, if you take with our structured development, it's the third phase. And then you focus on physical design. For example, in database, it's like you are going to create your database, right? So all the previous places, it might be you can think of conceptual and logical diagrams, but here you are going to physically implement. So that's part we are going to focus here. Now, if you look at in general, what activities usually you will see in system design phase, this includes user interface design, data design, and also the system architecture. And the outcome of these three stages will come as a report, and usually this is called a system design specification. Right. Now, when it comes to design space, remember we talk about developing information systems, and these systems should be effective. These systems should be reliable. These should be maintainable, right? So if you say reliable, what it means, you can handle input errors. For example, you might expect user to enter his or her name, or maybe person's email address, but you know that users can type anything. For example, if you're expecting an email, and if user doesn't enter the correct format, you should not, take that data in. So that's what we call input errors. So you have to handle these input errors, processing errors, hardware failures, and human mistakes. Then if you look at maintenance, it should be flexible, it should be scalable, meaning like you can increase or decrease the size of the system without problem, and also should be able to easily modify this. And you can say effective, it will basically support your requirements, and also if it will meet user needs. Right. Now, when you want to make a successful design, I mean, this is applies to even when you are designing systems, you have to always think the user's perspective. So for example, when you're designing a software and if you have a user interface, it should be easy to learn, right? And also you have to think about the future needs as well. The Y2K issue means like in the year of 1999, and I was in I was secondary students at that time. We entered the university in 1998 and 1999. Most of the time, most of the system built on those days, the year taken as 2 digits. Now you see the problem, right? So for example, 98 represents that 98 and 99. What happens next? Year 2000, the systems were not built to handle that issue. So because of this reason, lot of system got failed, and even there was a lot of issues came out uh, in computing area, especially in IT. So similarly, when you're designing a system, you have to think about what might happen in your future, and you have to develop system in that mind. And also like flexibility, right? For example, if you go to ATM and if you say, okay, what do you want to get back? Usually you will say, okay, they predefine set of, amount like 5,000, 10,000, 15,000, 20,000, and so on. So what if you have like in the account, you have 12,000 and you want to retrieve 12,000. So you should allow your user to enter the amount manually. So that's what I say. So when you're designing a system, you should provide all these options. Maybe user can, select what is existing. At the same time, you give the flexibility to the user to enter any amount, they want. Last one, manage data effectively. So data verification, type checking. So all these are very important. And usually nowadays you can see you use RFID scanners usually, where we can actually read the code. It's easily, verify uh, the data. Right. So let's start with the first part. We first talk about the user interface, then we can talk about the data design, because you already have done data design. So I don't think we can revisit that, but I think we better talk about the data interface. So when you talk about the user interface, we have to talk about how users interact with your computer system. So usually you will have a system, you have hardware, software, screens, menus, functions, outputs, and all these features simply to communicate with the user. It's a two-way communication with the user and the computer. And when you talk about this, you have to focus on human-computer interaction. So that means we can talk about the relationship between the computers and the people, right? So when you make those, you have to think from person using a smartphone to a very large, network. So if you particularly focus on the interface design, so these are the things you should, think about. For example, you need to understand the business first. So the ideal point is, if you remember, we discussed functional design diagrams, FTDs can be used, and you can use graphical effectiveness, thinking like a user, right? And also you can use models and prototypes. I will come to this point. This is called user interface storyboard. It's like before you developing or uh, creating a film, you will also create what we call the storyboard, which means you think about all these different scenes, and graphically you represent, and this is called storyboard. The same applies in the user interface design as well. So we can design, or we can elaborate our system design as a set of interface, and this is called user interface storyboards. Not only that, most of the time you have to think about the usability. You can select always the default answer, right? For example, you might seen in ATMs, for example, normally they won't give you a printed bill except you request it. The default is they selected it as no because they save paper. So likewise, you can see that you can focus on the usability. And always you should invite feedback. Most of the time, the problems can be solved getting a feedback from the user. And next one is you need to document all the information. So here are some examples of user interfaces. For example, you can see here like input box or text box, and you can sometimes have a message inside which reflects what you should type. And whenever you try to type something, it'll remind you that how many digits you have to enter, right? Then things like when you type and it will try to autocomplete. For example, when you type auto, and if you have this information in your system, it should pop up, say that, okay, you can select this value. So likewise, you can see there are a lot of user interfaces, user interface elements you can use. So the first one is from Windows, the Mac, and then these are like Android. Sorry. This is Windows. This is, I guess, okay, this is of course Apple. This is Android. I'm assuming that whether this is Linux. Anyways, or maybe this is Linux. I didn't remember exactly, but this is just to show you like how the same elements, their look and feel is slightly different, right? In different domains. Okay, remember I talk about, user interface storyboard, and this is one of the examples. So I want to maybe increase the size and show you. So in this particular example, what you see, right? So in this one, what you see is the example for user interface model or user interface storyboard, where this is actually represent the mobile app, and all these interfaces are selected with details. For example, this is the starting one. So the small circle, which indicates that this is the starting point. And this is the login. You see, we have, logo of the organization, and users are expected to type username. And this is login. But for example, if user does not, click this one, but don't have an account, and if user clicks sign up, then it should present it to this interface, where you will ask username, phone, and email. And when you click back, it can go back here, right? So which means, you sign it and then you are inside. So similar to that, in this is like home, where you can have some information about a person, and then you can have some activities which connects to the other ones. And inside here you have my stuff. So my stuff is here, my items, and all these connections are given, right? So that means it will show you, right, what each of these interfaces available in the system and how they are interact each other. Right. Similar to that, when you're designing interfaces, remember nowadays you have to think about, having them in various different sizes. The same design should be able to use in the mobile or the tablet or the Windows. So that also you need to think about when you're designing your user interface. Right. In this example, what you see is one of these main screens, right? In this example is coming from student registration systems, and these are the main, tasks a person can, perform within the system, right? So idea is user can click any of these actions, and then it will be present uh, the next set of activities related to the button the person selected. Right. Some suggestions when you're designing user interfaces. You need to create interface that is easy to learn and enhance user productivity. And you have to provide help and feedback, attractive layout, familiar terms and images, enhanced interface, focus on data entry screens, validation tools like what I said is email. If user enters something else, you should remind the correct format and reduce the input volume. So in this particular case, it will represent as a function decomposition diagram, which we have discussed early to show the menu hierarchy. For example, this is about the customer order tracking system where we have a main menu. Under the main menu, you have three categories: customers, orders, and the products. And each of the categories, we can say, for example, if you look at customers, you can add customers, update customers, and delete customers, and so on. It'll give you a complete overview of the business functions and processes. The other one is when you select a particular record, it usually pop up, another screen. For example, in this one, actually, when you say add a project record, so you are going to actually add a data about the project record, right? Similar to that, when you are designing systems, remember to fill or automate most of the values that users needs type. You should minimize them. For example, order number is usually generated by the system. So you don't have to enter this one. Usually this will decided by the system. And then date and time is automated. It's calculated by the system. And whenever you use customer ID, for example, if you use that customer ID, if you have the data in the backend, then you can present a customer's name. And then you can add items. So again, what you need to add is only the blue one. And then that means item ID and the quantity, and the rest will be automatically filled, right? So this is how you may try to implement something. Okay, so now that we have discussed about the user interfaces, next I would like to discuss about the different types of reports we can generate. So detailed report, it's produce one or more lines of the output, each report processed. An exception report, those records that mean specific condition of conditions. A summary report, or total figures to super level managers. That means upper level managers. So again, when you talk about the printed reports, it should be attractive, professional, and easy to read. And good report design requires effort and attention to details. Remember, it's not an easy task, right? And there are too many, how do you call this? Reporting details are given, but I'm going to skip for the time being. When you have multiple reports, your report should be uniform and consistent. Remember that it's very important, right? So the idea is you have a common design element. So you have agreed the common report design when you're producing reports. So here are some examples of how people have, grouped them in a typical detailed report. Then we have technology issues. So you have both output and input, and interface design should always be alert on the possible opportunities, potential problems of input and output. So output technology, again, in addition to the screen output and printed matter, output can be delivered in many ways. The system requires document properly identify the user output needs. So what are the output types? So you can have internet-based information delivery, emails, blog, instant messaging, wireless devices, digital audio, images and video, podcast, automated facsimile systems, computer output and microfilm, and computer output to digital media, specialized form of output. So input technology actually changed a lot in recently. For example, traditionally we use keyboard and mouse, but nowadays we have, voice recognition, for example, and then even the motion can be detected. But what comes in the future is brain computer interfacing, which means when somebody thinks, okay, switch off the light, if the system is work fine, it automatically switch off the lines. And then we have neural networks, artificial intelligence, advanced motion sensors, to satellite interfaces and virtual environments, which is, I think we can cover everything what we need. Right. So when it comes to input methods, there are two methods that you can follow. One is batch, which means you do it offline. For example, in a banking environment, day-to-day transactions are updated at the end of the day, for example. Or if you want to do it right now, then you can go for online inputs. Then data augmentation, this is a popular input technique. It's fast, accurate, and it can also minimize human involvement. Right. For example, POS terminals where you go and pay, or ATMs, right? We can use these popular alternatives. So whether to use it to batch or online input depend on your business requirement. Okay, the next thing is you have to think about is security and control issues. The output control includes the physical protection of the data and reports, and control of unauthorized hosts or devices that can extract data from your system. So you can also have audit trials, encryption, password security, data security, and creation of access limits. So what are the strategies we will have to avoid many problems? Two strategies to avoid is modular design approach, and we can use prototype. So what do you mean by modular design? So you can create individual components called modules, and it can use to connect higher level programs or processes. Structured design, each module represents specific process, which is shown in data flow diagram that we have seen earlier. In object-oriented design, object and classes are represented by the code modules. So we can actually learn more in the implementation. So the module design is especially important in design large-scale scan systems, because separate teams of analysis and programmers can work on different areas and then integrate the results. Okay, next one is prototyping. I told you like the initial stage why we use all these user interface design and all is we have to please our user. So prototyping is another way that you can actually create a rapidly working version of the system. So that means if you're asked to be the, let's say, store registration system, you can simply develop a prototype of the system. You don't have to implement all the features. You can implement one or two key features and then you can take it as a prototype, right? So one thing that we need to discuss is there are two types of prototyping. We can use either single system level prototype or design level prototype. Right. With that, I think we conclude our discussion on user interfaces. So therefore, I will put you in groups to work on uh, what we discussed here. So what I'm going to do is I'm going to upload these slides so you can talk about how you are going to do. But what I need from you is the proposal for the user interface. So the idea is you first start as a information system. You can think about a particular user interface, and then you can build it as a kind of um, user storyboard that we have seen early, where we can, present how, for example, the first interface is connected to the second interface and so on. But when you're doing, think about the principle that we have discussed. You have to think like a user, and then also you can also think about the data validations, right? In what places you should check for data validation. Okay, so with that said, let me copy paste this one. So this is a group work 6, and then I'll put you in groups. Okay, but before we put in the breakout room, let's mark the attendance.